Alrighty. Again, thank you so much for having me. My name is Josh Lovejoy. I am a designer, and I help to lead a group of folks working at Microsoft that is a mixed discipline organization where we collaboratively work with first-party product teams, so inside of Microsoft, to try to collectively answer the question, what does it mean to build things responsibly? We are not a philosophy think tank. We are not a white or ivory tower. We are not a group that fancies itself as people that decide what's right or wrong. Far from it. We try to be really applied and focused because the reality of trying to ship things into the real world is messy, and more often than not, far more often than not, the types of unintended outcomes or consequences or harms that technology helps to bring about are caused by ignorance or lack of awareness more than they are malintent. So our team really tries to create space, and more than anything, time to just have conversations, especially across disciplines, which is why I'm so happy to be talking with an NLP community. As a designer, I just get really excited to be able to cover all sorts of different groups, from legal to data science and beyond. There's a lot of us. What I'm going to talk about today, though, are not the applied work. Our team has done a whole bunch of stuff over the last 3 years, from working with US military around HoloLens implementation to ways that we can responsibly put forward synthetically generated speech content, and ways that we can actually limit access to things that can promote misinformation and disinformation, to restructuring the way that we think about consent for product improvement, for AI-powered systems. There's a lot of stuff that we work on, but what I wanted to talk about today actually is a little bit more like an essay. There are a number of things that I have just sort of been hoping would come about for a long time, and I really genuinely wanted to hold off on talking about it until I had more proof points. And my challenge is that I think there are some things that aren't being discussed, and then we need to be able to take them for granted, and that's not the case yet. So we all have to put our minds and hearts together to actually make it true. So it starts with something actually probably which is the hardest, which is understanding or recognizing what the most probable future outcome would be for the product or technology that we're working on. The thing that would just happen by default if we didn't do anything to, really tangibly affect change. What is the most probable future? That's really hard. And oftentimes we don't stop and ask. We take for granted a lot of the things that are happening around product planning or product market fit analysis, or the sources of the data that we are drawing from. But with a sense of what's the most probable, we can take a much more expansive view and understand what's possible. And this really does involve talking with people across disciplines, social science, law, policy, design, research, both theoretical and applied. And again, trying to figure out what that broader scope looks like, possible futures. So we can go from probable to possible. And with that, then we have to do the really uncomfortable thing, I believe, which is understanding and identifying what we believe the characteristics of a preferable future are. And I'm using a lot of language to try to soften this because it's uncomfortable to try to make a statement, an opinion about what you think, what I think is preferable. Who are we might ask ourselves, to say we know what's right or what's better? But at the same time, and what the tech community, I think, or the AI community more broadly has been really challenged by, is if we don't talk about it, then we're pretty well guaranteed to end up with that probable future, the things that go without saying future. So step one is actually to talk and make it okay to talk about what you believe is a preferable future, so that we can understand if we're not hitting it, or maybe we need to involve other people. To that end, I want to talk about 3 areas, and I'll probably try to speed up a little bit to get through a lot of these things, because there are a number of core concepts. Nina, hold me accountable on time so that we have enough space for Q&A. Feel free to jump in. The first one is about capability. And again, this is like, I'm just going to pick an arbitrary timeline, something like the end of 2022. I want to be able, selfishly, I want to be able to take a few things for granted. And that's really the crux of what I'm going to go over today. Because most often when I get involved with teams, I'm surrounded by thoughtful, kind, well-meaning people who are missing some of the fundamentals for what's different about machine learning and AI. So capability. So what's uniquely AI and what's uniquely human? There's a lot of good literature on this, and I'm going to simplify it down into my own implementation or my own interpretation of it. I do this because I think it's important for us to try to not replace people as a default setting. But oftentimes we see that as a default setting. We use words like human parity, for example, when describing characteristics of model optimization. But it's uniquely human to thrive on novelty and creativity. We do get easily distracted at the same time, while it's uniquely AI to thrive on repetition and never lose focus. Again, human parity becomes kind of a quirky thing when we look at it through that lens. Similarly, it's uniquely human to receive a lot of stimuli all at once. We are a multifaceted, multi-sensory perception animal. We have cells that do all sorts of different types of things, and they are very, very, very specialized, but they also work in as a collective. You know, that's what our brain does. Whereas machines they're insensitive to mood or distractions. Mood or distractions are cognitive quirks that we've developed as survival mechanisms. Machines don't need these things. They don't have moods. It's uniquely human to ask questions out of pure curiosity. We're just kind of need to explore. It's how we continue to adapt and evolve. Whereas machine systems can respond instantly and multitask with precision. They can do super, super specific things, and they're not going to get bored because they're more curious about, you know, counting something different. And finally, it's uniquely human to adapt behavior rapidly, but forget details of past events, right? Our memories are fallible. Our memories are hallucinations. We enter into some form of what our brain is doing its best to recreate the conditions where we had the initial experience. Whereas machine systems are actually representing some sort of statistical numerical representation, but they're gonna, as a result, struggle to unlearn past patterns, right? Because they're more indelible. So there's some significant differences. Suffice to say, there's some significant differences between people and AI. And when we start with this default assumption that we can kind of recreate human characteristics through AI, or we can sort of make people more efficient like AI, we're actually doing quite a disservice to the things that really help them stand apart. So a few things that are just sort of quick examples of some of these distinctions, like it would be exceptionally boring to try to do this kind of activity of opening and closing a door all day. It's very uniquely AI. This is incredibly basic, right? There's a light sensor and a light curtain that if it's obstructed in any way, the door opens. It's a simple state. There's no determination about the size or shape or characteristics of a person that determines what can open and close this door. It's literally just the obstruction of light. Gets much more profound, right, in terms of the things that are uniquely possible because of that focus, that attention, that memory. This is the Seeing AI app that allows predictions to be formed from a pixel-based representation that can convert objects or physical space objects into engrams in this case, right? So detecting the physical presence of characters in sequence, and then turning that into a speech, text-to-speech output so that somebody who is blind or low vision can hear what the phone sees. So again, all these things this borderlines on magic, or a magical experience, because it's doing a very focused task in a very intentional way, but collecting over tons of training data to be able to make some of these distinctions possible. All the way out to really out there generative content. This was one of the, I think, really forebearers of synthetically generated content. It's a super resolution, which still blows my mind to think about changing the actual sampling of an image by asking a machine learning system to generatively infill. So looking at the blank spots as an image is stretched and saying, hallucinate out the pixels that could be there, based on a huge exposure to massive corpuses of information about just things in the world. You know, this is These are all exceptional capabilities. They are very uniquely AI, exceptional uses of it, and there's no replacement of human beings in these processes. If anything, there's a real augmentation. Now, conversely, there's a lot of examples recently about doing something like face mask detection in physical spaces because of the world we live in. And this one kind of always strikes me that when I talk to teams, because they're not considering what's uniquely human in these scenarios. It's exceptionally awkward to go up to somebody, and I can just speak, here in America, it's exceptionally awkward to go up to somebody and remind them that their mask isn't on or that their mask is slipped. Should it be awkward? No, but is it? Yes. And that human labor is something that you can't just automate by having a face mask detection that produces some sort of alert and says, hey, people aren't wearing their face mask, go do something about it, right? What's far more humanist is to do something like maybe having a screen that projects back something so that people can self-correct their own behavior, or something that can measure in a privacy-preserving way aggregated statistics about locations and entrances that have higher incidence of people not wearing face masks, and then have people go together to get emotional support from their colleagues as they might want to talk to a shopper, or in this case. Regardless, these are complex human-to-human collaboration situations, and the system alone, there's no really such thing as good or bad or accurate or inaccurate without taking account for the human characteristics. Okay, so capability, thinking through really those situations where people are doing uniquely people stuff, and the things that are uniquely possible with machine learning. Something I wish I could take for granted. The second is accuracy, and this is kind of unfolding into kind of like the layers of the nuance, but I hear accuracy used all of the time, and I often have to ask these follow-up questions like, well, what does working as intended mean to you? How blank is blank enough? If you're doing something like detecting engagement in some sort of physical space, how engaged is engaged enough? How close are they to something for you to actually care about it? And the close, I would say, partner with accuracy often ends up being fairness, because we'll look at an output of a system, such as an image search, and it will read to many of us as unfair, which again is kind of a proxy for inaccurate. And I push on that, because I think we can actually have more substantive conversations if we talk about in the intentional measurement. How do we expect to measure accuracy versus how do we expect to measure inaccuracy? So in this case, again, some folks might look at it and see those results and say, huh, that seems like it's missing something, some part of the population. And down one path, we could say, well, if the optimization here was something like a natural language fill-in, which is what it's doing, of understanding who the most referenced physicists, or perhaps the most frequent, the physicists with most frequent citation or something, whatever it might be, or most likely a heavy dose of pictures of physicists that have been most frequently clicked on as a high school student is making a PowerPoint presentation. But that's the optimization thing, right? So you're talking about a fill in the blank. And we would call that accurate because it's more of an objective characterization. On the other side, the question could very well be, what can a physicist look like? At which point this becomes an inaccurate or unfair characterization, because this is extremely limiting to half the world's population who might be, little girls growing up and saying, is it possible for me to be a physicist? The internet seems to tell me it's not. So if we don't understand this kind of optimization, like AI optimization that quote unquote fills in the blanks, and we understand how we would measure what kinds of accuracy we're looking for, then it becomes challenging, because then the value tensions make these questions about fairness or unfairness. But I think we can get more granular, more precise. So I offer a 2x2 on this one, because who doesn't love 2x2s? And I brought in a term from social science and cognitive science about perceiver dependence. The concept of perceiver dependence is really another way of, I think, a more accurate way of talking about objectivity versus subjectivity. So in a perceiver dependent scenario, the idea would be that if you ask a couple different people their life experiences, their context, who they are as a perceiver would actually affect their perspective. Whereas a perceiver independent characteristic is something where if you ask all those different people with their different experiences, their different stories, their different contexts, they should have the same response to it, right? So some examples, and I'm going to use like a speech recognition case here. So we would say things that should affect accuracy. Interruptions. Who gets to classify what an interruption is? An unfamiliar word. Unfamiliar to who? Enunciation level. What some people might talk about as an accent might be totally recognizable to people that are local to that region or part of the world. On the flip side, again, things that are going to be distinct by perceiver. Gender identity. Are we all going to be as accurate at being able to perceive the person's gender just based on their outward experiences or their outward presentation or how they talk? Their accent. Accent is, again, very much something that's a perception or a construct of your local environment. My older kid recently was like, Dad, I think I should, why don't I have an accent? And I'm like, oh, child, you have an accent. We've just done a poor job of exposing you to the rest of the world, apparently. And age, we often do a pretty bad job as perceivers of really understanding people's age just based on their presentation. But the way that I would split these two things, again, in this 2x2 is, on the left side, we should expect these things will affect accuracy, right? The collision of phonemes in something like enunciation absolutely should have an impact. If phonemes are really compressed together, it's just going to be intrinsically hard for the system to recognize the presence of distinct phonetic expression. Whereas something that shouldn't affect inaccuracy, right, shouldn't lead to failure, how the person looks, how they're perceived as a gender, how they're perceived in how they talk, how they're perceived and how old they are. But if we don't know how to measure for them, then we can't tell if it's not working, right? So what I'd say we have to take away from this is not to assume failure, but to ask ourselves, how would we measure a failure or an inaccuracy that's related to gender identity? How would we measure an inaccuracy that's related to age? And those are hard questions. On the perceiver independent, again, these are things that should be fairly objective. It shouldn't really matter how quickly the person talks, which I would say is words per minute. It shouldn't matter the frequency, the vocal pitch that they're speaking at. But again, the mic they use might have an impact there. The pauses probably shouldn't affect it. And so this could be things around disfluencies and different ways that people might present the order of their words, or even might introduce some of these kind of words that I'm using right now. And then finally, things that should affect accuracy, but should be pretty objective. How close somebody is to the microphone matters. And we should probably all be able to agree how far you are from the mic. The decibel level of speech matters to accuracy, and we shouldn't have a debate over decibel, nor of the background noise. A noisy environment should be intrinsically more hard to measure. So I just present this. The goal of trying to present this is not to solve all the world's problems or even forecast out every single possible scenario that accuracy or inaccuracy could happen. It really goes back to just do we know how to measure for something about that preferable future we've been talking about? Do we know, generally speaking, how we could get signal if something isn't working as intended? That's the whole point. We just have to start those conversations. And that leads to the last category. And in an essay I wrote recently, I called this learnability. And I've been kind of going back and forth because ultimately the reason why I think about it as being learnable is because of the importance of people in any system. We are the data sources of all things. We are also the authors of all things, and we are the users of all things. So people are involved at every point. And the question is, what do we need to be accountable to? And so I would sort of think if people don't know how to use it, which is to say it's not learnable, how the data are structured, where the data come from, how the system operates, how the system might lead to unintended consequences, whatever it might be. If people don't know how to be confident about what the system does, then how could they possibly be accountable? But I think about this a little bit more directly in accountability because again, there's just this category of stuff to take for granted. And this one has been really a standout and it's in the category of trust. Because we often talk about trust as an aspiration. When we build systems of any kind, the goal is to gain trust. And my colleague, Arthi Sethumadhavan, who leads our research team, has this brilliant thing that she always pivots on. She says, appropriate trust. What's the appropriate level of trust that people should have with a system? Because it's totally possible to gain somebody's trust, but abuse that trust, right? So the insight here is looking at how trust is actually formed. And when we think about accountability, I think it's important to understand what leads people to trust. So the great mapping here is that in human-to-human relationships, we're actually already we have a pretty good understanding about dynamic and probabilistic systems. When you interact with another human being, you are interacting with the most dynamic and probabilistic system in the known world, another human mind. And as a result, we've built all of these great adaptations about how we build trust with one another. So it starts from trying to build a predictive model. Everything in the human cognitive experience is prediction oriented. That's our big breakthrough. From that, it grows to dependability, right? What can and can't, or should and shouldn't I depend on this person for? And how do I build up evidence over time? And then ultimately it leads to faith, where you can actually start to offload a lot of those cognitive resources in prediction, mapping, and error correction into just sort of knowing with good levels of certainty that somebody's going to be able to do what they should be doing, right? So with different professions, we sometimes offload faster. Like with doctors or teachers, we jump to faith faster, but there still are these core on-ramps to trust. My favorite example of this in my own work was doing a project around the deaf and hard of hearing experience, and trying to build computer vision recognition and natural language systems to try to do something to augment the American Sign Language experience or the sign language experience. And there was this amazing insight from the interpreters. We had this one moment where one of the participants wasn't able to make the session, and so we were there with 2 sign language interpreters, and we just got to talking, and I let slide part of my ignorance, which is like just an assumption of trust. Like, wow, it's so amazing that you get into these experiences and there's just such an immediate trust, they have to rely on you. And they were like, no way. The first like 5, 6, 7 times that a person who is deaf or hard of hearing works with a sign language interpreter, they are watching, if they have the ability, they are watching that interpreter like a hawk. And they're really, if they have their preference, they are taking them to environments that are very low stakes initially, because interpreting is interpreting. They are not going to catch every single sign and properly vocalize it, but there's a whole lot of lip reading going on after the fact as the deaf or hard of hearing person is watching, observing the way that the sign language interpreter is vocalizing, because they just don't know, what details do they skim over? What details do they remember? And it's only after there's a trust level built based on predictability, dependability, and then ultimately the ability to offload to faith that they are more confident in bringing them to a higher stakes meeting, like a meeting with a doctor or a lawyer. So going back to that trust ramp, then what's different about machine learning? And this is like, if you take nothing else away from this conversation, it's automation bias. It's like the fracture in the whole mental modeling activity of building AI that has not been adequately addressed to date, which is that people are virtually guaranteed to over-rely on the outputs of automated systems over human judgment by default. They're perceived as more objective, as more mechanistically efficient, all these things. And as a result, it leads to this automation conundrum, which is as reliability increases and robustness increases, people offload to the point where they actually lose track or lose understanding about what's happening. So why is this important in that trust building process? So if this is human to human trust, it's actually very similar with a key distinction for human AI trust, which is that we essentially start on this cliff. We are super high trust, right out of the experience. Anybody who's ever followed a GPS and then cursed at it because it took them the wrong direction knows what I'm talking about. We start with this high automation bias. And at some point, there's a realization of fallibility because it's a probabilistic system and because that's why we use it. It's great. It's wonderful to have these systems that can form opinions and intuition. But nevertheless, when that fallibility happens, there's going to be a fall. And so my sort of charge to the broader community is, how are we preparing for that realization of fallibility? How are we building with the expectation that human beings will need to build predictability, they will need to build dependability, and they'll need to work up to a state where they should have appropriate trust? We have to balance these two things, knowing there'll be automation bias and then being ready still to build up the relationship. This is the underlying issue behind the self-driving car accidents where human oversight is expected. And in the case of the Uber car, it's downright foolish, and I think we'll have a very different type of legal landscape in the coming years, where they expected a single person to be perfectly vigilant, operating as the fallback for the car. The car detected that there was a bicyclist, but it wasn't sure, and so it was like, hey, human, take over the wheel. People suck at that. We can't do that. We're not good at maintaining constant vigilance. If you go back to that distinctly human and distinctly AI thing, when people get out of the loop, we're out of the loop. Right? So we have to understand that if we're trying to build trust and understanding, a lot of that has to do with our own level of control and oversight. We follow these into two different categories. I'm actually going to skim over this pretty quickly, but misuse and disuse are part of the same fabric. They really just come down to a lack of understanding or appreciation for the capabilities or limitations of a system. Misuse is when people know and use it anyway. Like, this isn't for this, but I'm going to use it anyway. And disuse is when they don't know and they just chalk that up to like a bad design. But all of it comes down to, again, an understanding about the role of people in the system. And so this is like the last main point I'm going to try to land in this verbal essay, is that automation is not a binary. It's not just an on-off. There is an immense level of complexity and granularity, I should say, in the work that we do from a design perspective. So when we say build up an automated system, there are actually 10 levels and 4 categories based on this framework from Parsuman and others from the very early 2000s. And it scales from complete manual everything to decides everything, and there's literally nothing happening, and it'll ignore people. And that spectrum with a handoff right in the middle, where it's like it offers a decision or action for a human to approve. It's great to have that middle ground to think through, because these 4 phases actually have pretty distinct design objectives. So if we think about the distinction between something like a lane assist automation in a car that can do things like lane detection and lane warning or collision warning, versus autofocus in a camera, which really is just doing its primary activity when it can sort of produce a number of potential bounding boxes around likely objects, mostly faces, for the photographer to choose from, but then it goes full auto. Once the decision is made to capture, control is completely out of the hands and the eye of the photographer, and it goes to full automation. Whereas inversely, when a car is doing its stuff, people have no control over the sensing of lane demarcation, of road conditions, of proximity to vehicles, of what it even means to look for other vehicles or other lane demarcations. That stuff is fully automatic. And at some point, though, the driver is deciding to change lanes, and that's on them, right? So this is where it gets into the issue of like, if they expect that, yeah, I don't need to do a shoulder check. I didn't hear a beep. I can just turn. The accountability is on the driver. But the system design, the automation design there, it's really critical for how we did decision selection. So it all comes back to a fundamental question, from capability to accuracy and to ultimately what makes something learnable, is, do we know what a person actually needs to be confident taking accountability? If we can start with that question and ask the actual people who will use these systems and be affected by these systems, we'll get really interesting conversations. And that's where I'd love to be able to jump to sooner. I'm taking this approach right now, working on a team with a bunch of different teams that are trying to implement like GPT-3, for example, where there's a vast array of potential things that we can do with transformer models and natural language generation. But if we can't start with this core question, then we won't know what we don't know from a human in the loop perspective. There's a few key details, that are sort of axioms of HCI at this point, or situational awareness, mental workload, complacency, and skill degradation. All of these things really come down to the essence of the role of accountability, right? For someone to be accountable, then we need to have considerations for, how much cognitive overhead there is, for how much attention they need to be able to have to the activity in the core context, their likelihood to rely or even over-rely, and then of course their ability to stay fluent in the skill itself. So these are all things that we have to consider. People aren't going to tell us they need this stuff. We just have to know about it. And I close, and there's some stuff in the article about this, just to offer a few kind of quick examples of learnability or things that we can integrate into interfaces that might seem subtle, but offering multiple paths, for example, like how we can scope these things down so that we're making people less beholden to singular outputs, and actually let them explore a broader range on their own terms. Or ways that we can let them simulate possible futures and look at trade-offs. Everything we do in machine learning, everything we do in automation has trade-offs. We just often try to cover up those trade-offs. In this case, flexibility or directness, or average speed versus likelihood of being delayed at an intersection. And then one of my favorite ones to talk about is how we can actually sort of simplify the error states, where if we have low confidence predictions or low confidence matches, let's be honest about that low confidence. Sometimes the worst thing we can do is offer the 40, 50, 60, 70% confidence thing, because that then leads people to distrust the 90 and 95% confidence scenarios. So how do we actually take it as a chance to build a learning loop where people can teach the system in a privacy preserving way how they talk uniquely, in this case about transcription. And this is like a jargon term we use in tech. We say CSAT for customer satisfaction. That's not a real word. It doesn't exist. So we can try to guess, or we can try to be honest about low confidence. So I know that was a whirlwind of stuff. 3 different categories, 3 different things I'd love to take for granted. I think you probably can see why at this point it's been challenging to take them for granted, because there's maybe a lot going on in terms of the nuance. And so, I'll sort of leave by saying, if we can design systems that honor people's capability by helping support self-reflection, if we can think about accuracy more in terms of mismatches between people's expectations and the outputs of systems, and if we could think about accountability really through the lens of usability, what helps people build confidence in themselves, then I think we're really set up for success. Self-reflection, mismatches between expectations and outcomes, measuring those mismatches, and then usability and learnability. What does it take to feel like you can be effective as a user? Thank you so much. Really appreciate it.